Now let's discuss the concept of cyclicity. We'll first look at the case of unit digit cyclicity. The concept of cyclicity is used to find out the last digit of any number raised to any power. For example, if I have a number ABC and I raise it to the power xyz, I expand it and I find out the number, and I only have to look at the last digit of this number. So the concept of cyclicity helps me finding out the last digit or the unit digit of a number raised to any power. In order to do so, I would only look at the unit digit. So I will only look at C here. I will not look at the rest part of the number. The unit digit will only depend upon the unit digit. It will not depend upon the tens place or the hundreds place digit. Now for example, if I have to find the unit digit of this number, I will only look at the unit digit. That means I will only look at the numbers 7 and 6. The rest part of the number, this, would be immaterial to me. The final last unit digit would be given by multiplication of the unit digit 7 and 6 to give you what? 42. I will only keep the unit digit, which is 2. I will not look at the tens place or hundreds place digit. So before we move on in how to find out the last digit, we'll look at the cyclicity of certain units digit. So let's start with the case of 2. If I look at 2 raised to power 1 ends up in 2. 2 square, last digit is 4. 2 cube, it is 8. 2 raised to power 4, it ends up in 6. I am not talking about 16 because I am only taking the unit place value. 2 raised to power 5, 32. 2 raised to power 6, 64. So I will keep 4. 2 raised to power 7, 128. I will keep 8. 2 raised to power 8, 256. I will keep only 6. 2 raised to power 9, 512. Keep 2. 2 raised to power 10, the value is 1024. I will keep only the last digit, which is 4. Now once I do all of these things, I will observe that 2486, 2486. So what is happening? This thing is getting repeated. So I have a cyclicity of 4. Unit digit cyclicity has a cyclicity of 4 if I talk about the last digit to be 2. Let's look at the case of 3 now. If I am looking at the cyclicity of 3, I will follow the same thing. 3 raised to power 1 ends up in 3. 3 square, 9. 3 cube, 27. I will keep 7. 3 raised to power 4, 81. I will keep 1. 3 raised to power 5. So I will only keep the unit digit and I will not keep the rest of the digits. So if I keep on writing the unit digit, I will observe that they again have a cyclicity of 4. So the unit digit of a number ending with 3 raised to any power are repeating in a pattern 3971, 3971 and so on. So I will again say unit digit 3 has a cyclicity of 4. That means the repetition cycle is 4. Let's look at the case of 4 and 5. Now if I talk about 4, 4 raised to power 1, 4. 4 square ends up in 6, 16. 4 cube, 64 ends up in again 4. 4 raised to power 4 ends up in again 6. 4 raised to power 5, 4. I am talking only about the last digit. So if you look at it, it is 4, 6, 4, 6, 4, 6 and so on. That means this digit of 4 has a cyclicity of 2. So either the last digit for a number ending with 4 raised to power anything will either end up in 4 or 6. That will depend upon the power. If the power is odd, it will always end up with the last digit as 4. If the power is even, 4 raised to power anything which is even, the last digit would always be 6. So it has a cyclicity of 2. That means either the last digit would be 4 or 6. 4 will be the last digit when the power is odd and 6 will be the last digit when the power is even. Let's look at the case of 5. 5 raised to power 1 ends up in 5. 5 square, 25. 5 cube, 125. 5 4, 625. So 5 raised to power anything ends up with the last digit as 5. Very, very important. So I would say unit digit of 5 has a cyclicity of 1. That means it is the same unit digit which is repeating itself. So if a number ends with, if a number ends with 5, raised to power anything would always end up with the last digit as 5. 5 raised to power anything would always end up in the last digit as 5. Let's move ahead and look at the case of 6 and 7. 6, if I talk about 6 raised to power 1, 6, 6 square, 36. 6 cube again ends up in 6. 6 raised to power 4 ends up in 6. 6 raised to power 5 ends up in 6. So again we can say that unit digit 6 has a cyclicity of 1. That means again 6 raised to power anything. If the unit digit is 6 and the power is anything, it will end up with 6 always, all the time. My last digit would be 6. Similar to the case of 5. Let's look at the case of 7 now. 7 raised to power 1 ends up in 7. 7 square 49 ends up in 9. 7 cube 343 ends up in 3. 7 raised to power 4 2401 ends up with 1. 7 raised to power 5 ends up with 7. 7 raised to power 6, if I look at it, ends up in 9. The powers have been written wrongly. Yeah. 7 raised to power 6 ends up with 9. 7 raised to power 7 ends up with 3. And 7 raised to power 8 would end up with 1. So if I look at the case of 7, I would observe that there is a cycle size of 4 which is there. 7, 9, 3, 1. 7, 9, 3 and 1. So unit digit 7 has a cyclicity of 4. It has a cycle size of 4. Let's move ahead and let's look at the cyclicity of 8 and 9. 8, if I look at it, 8 raised to power 1, 8, 8 square 64. 8 raised to power 3 will end up with 2. 8 raised to power 4 ends up with 6. 5 again ends up with 8. 6 ends up with 4, 7 ends up with 2 and 8 ends up with 6 again. So if you look at this case, 8 again has a cyclicity of 4. Unit digit 8 has a cyclicity of 4. Let's look at the case of 9. 9 raised to power 1 ends up in 9. 9 squared 81. 9 cube 729. 9 raised to power 4 again ends up in 1. 9 raised to power 5 ends up in 9. So if you look at it, it has a unit digit cyclicity of 2. 9 and 1. 9 and 1. So 9 raised to an odd power that I am talking about would end up always with 9. 9 raised to an even power would end up in 1. So this is similar to the case of 4. Because the cyclicity was also 2 in case of 4. So let's move ahead and let's look at the cyclicity combined for all the numbers. So if the last digit is 0, 1, 5 or 6, for all of these unit digit, the cyclicity is 1. So that means if the last digit of any number is 0, 1, 5 or 6, raised to power anything would always end up in the same unit digit. So if a number ends with 5, it will always end with 5. If a number ends with 6, raised to any power, it will always end up in 6. The unit digit 2, 3, 7 and 8 have a cyclicity of 4. As we have already discussed, 2, 3, 7, 8 have a cyclicity of 4. The unit digit 4 and 9 have a cyclicity of 2. So I have categorized this 4 raised to power even and odd because the cyclicity is 2. Again 9 raised to power even and odd because the cyclicity for this is 2. So this is how we find out the cyclicity for all the units place. Now it is not necessary for you to actually find out the cyclicity when the question comes into exam. So what you need to know is you need to just concentrate here and just look at this table and remember it. So this is a very, very important table that we have that we need to remember when we are doing questions related to cyclicity. Once we have understood this concept of cyclicity, let's look at how to solve the question. So what are the steps that you need to take to find out the unit digit? The steps would be as follows. First step, identify the unit digit of a given number. So number is given to you. I will not look at the entire number. I will only look at the unit digit of those numbers. I will not look at the tens place or the hundreds place or the thousand place digit. Second step would be finding out the cyclicity of that unit digit. Since we have already done numbers like 2, 3, 7 and 8 have a cyclicity of 4. Digits like 4 and 9 have a cyclicity of 2. And digits like 0, 1, 5 and 6 have a cyclicity of 1. So I will look at the cyclicity of that unit digits. So let's look at the question that we have. The question is, find the unit digit of this number 5672 raised to power 2345. I will first identify the unit digit. What is the unit digit that I have? I will not look at the rest part of the number. I will identify 2. Then step 2, I will look at the cyclicity of this unit digit. So cyclicity of 2 is 4. That is what I've understood. The cyclicity of 2 is 4. That is what I need to remember from the cyclicity table. The third step would be divide the power of the given number with its cyclicity to find out the remainder. So what is the power that I have? 2, 3, 4, 5. I will divide that power with cyclicity. What is the cyclicity of 2? It is 4. Divide the power with 4 to find out the remainder. So instead of dividing 2, 3, 4, 5 with 4 to find out the remainder, I would apply the divisibility rules. You have already learned the divisibility rules. The divisibility rule for 4 is looking at the last 2 digits only. So I will look at the last 2 digits, which are 45 in this case, and apply the divisibility rule instead of the entire number. So this 2, 3 also is immaterial to me. I would look at 4, 5. 45 when divided by 4 gives a remainder of 1. So this entire number would also give a remainder of 1. So I found out the remainder. The remainder when 45 is divided by 4 comes out to be 1. The last step would give me my answer. The last step is the final unit digit would be whatever is your given unit digit raised to power remainder. So whatever is the remainder that you have got, the remainder that I have got here is 1. So my answer would be 2 raised to power 1, which will be 2. So the unit digit that I'll get for 5672 raised to power 2345 would be 2. So these are the 4 steps that we need to follow in order to find out the unit digit of any number. A word of caution is, if the remainder comes out to be 0 on division with 4, that does not mean my answer would be 2 raised to power 0 and 1. You would have easily seen that when we have done the cyclicity for 2, the number ends with either 2, 4, 8 or 6. It does not end with 1 anytime. So a remainder of 0 is actually equal to a remainder of 4. When you get a remainder of 4 on division with 4, you call it as a remainder of 0. So my answer in that case would be the answer for 2 raised to power 4, which will be 6. And not 2 raised to power 0, which will be 1. So the only thing that you have to take care is, when you are getting a remainder of 0, that does not mean it will be 2 raised to power 0. It will be 2 raised to power 4 if you are dividing it with 4. If you are dividing it with 2, it will be 2 raised to power, if you are dividing it with 2, which is the case of 4 and 9, it will be that unit digit raised to power 2. Let's look at an example. The question is, find the unit digit of 512 raised to power 2487. So the first step is look at the unit digit. What is the unit digit? 2, right? And then look at the cyclicity of 2. What is the cyclicity of 2 that we have? The cyclicity of 2 that we have is 4. So you look at the unit digit 2 and look at its cyclicity. The cyclicity is 4. Then divide the power. What is the power that you have? 2487 with 4 to find out the remainder. Now instead of that, I will follow the divisibility rule and I will only check the last 2 digits on division with 4. Now I know 88 is divisible by 4, so 87 would leave a remainder of 3. My answer will be the unit digit raised to power the remainder. So 2 cube, the last digit would be 8. The unit digit of this comes out to be 8. It's a very simple process. Look at the unit digit first, look at its cyclicity, which is 4. Divide the power with cyclicity to get to the remainder. That unit digit, whatever you have, raised to power remainder would give you your answer. Let's look at another question. What is the unit digit of so on? So if I look at it, I hope you understand what is factorial of a number. Factorial is you multiply all the natural numbers starting from 1 to that number. So if I'm finding out 2 factorial, it will be 1 into 2. If I'm finding out 3 factorial, it will be 1 into 2 into 3. 4 factorial, 1 into 2 into 3 into 4. So the value would come out to be 2. It is coming out to be 6, 24. 5 factorial is 1 into 2 into 3 into 4 into 5, which is 120. So if I look at 6 factorial, 7 factorial, all of them, this will basically be 1 into 2 into 3 into 4 into 5 into 6. So I can replace this with 5 factorial into 6. So this will be 5 factorial into 6. 5 factorial ends up with 0. So 6 factorial will also end up with a 0. 7 factorial will also end up with 0 and so on. So if I look at it, 1 factorial ends with 1, 2 factorial ends with 2, 3 factorial, this value is 6, 4 factorial, it ends up with 4. 5 factorial, it will end up with 0. All the numbers greater than 5 factorial will always end up in 0. So if the unit digit is 0, you keep on adding zeros. It will not change your answer. Your final answer would be 1 plus 2 plus 6 plus 4 plus all the zeros that you have, which will not change your final value. So it comes out to be 13. Your final answer would be 3. 3 will be the unit digit of all of these cases. So our answer will be 3. Let's move ahead and let's look at, this is what I've already explained to you. So there will be only 4 terms. So the unit digit that will come out to be is 3. Let's move ahead and let's look at the case of tens place. So if you have to find the tens place digit, whatever we have done till now was for units digit. We have not looked at the case of tens digit. So there are various methods that we can use to find out the tens place digit. The first method is the remainder method. Remainder with 100 gives you the last 2 digits. Though we have not done the concept of remainders as of now, but we'll do it as we move along the presentation. So you can just learn the concept for the time being, that remainder with 100 would give you the last 2 digits. If you have to find out the last digit, the method where we have just done, last digit is also the remainder with 10. So if you find out the remainder with 10, it will basically give you the last digit, because if you look at it, this is the number that you have, you multiply it with the place value and this is the number that you get. So except the unit digit, every number is a multiple of, has a place value which is a multiple of 10. So all these numbers would not give any remainder with 10, they will be divisible with 10. So if I have to find the last 2 digits, I will divide it with 100. All the numbers greater than the hundreds place digit would be multiples of 100, and therefore I will get only last 2 digits as my remainder. So example that you can take is 568. If I divide it with 100, 500 plus 68, I'll be left with the remainder, which is 68, which is basically the last 2 digits that we have. It is written as 500 plus 60 plus 8. This number is divisible by 100. These two are not divisible by 100, giving an answer of 68. So if I have to find the last 2 digits of a number, like the thing that we have done in the unit digit, I will only look at the last 2 digits. I will not look at the last the full number. I would look at only the last 2 digits, which is 21, 47 and 18. Multiply them to get to the final value of the last 2 digits. Because if I have to find the last 2 digits, I will only look at the last 2 digits. Now if I have to find out the last 2 digits, I can multiply them and divide it with 100. Now if you remember, the remainder with 100 gives you the last two digits. So when you multiply them, divided with 100, you will get 66 as your remainder, which is also equal to the last two digits. Let's look at method 2. The second method that we learned today is the method of cyclicity, like the one which we have used in finding out the units place thing. So if I look here, cyclicity of tens place exists similar to the units place digit. So list of cyclicity of digits for tens place is as following. So we are not going to derive all those things. We have already done it for the units place. We'll only remember the results. So if the digits are 2, 3 and 8, it has a cyclicity of 20. If the units are 4 and 9, they have a cyclicity of 10. 5, this has a cyclicity of 1. So if a number ends up with 5, the last two digits will be 25 always. So if the digit is 6, it will have a cyclicity of 5, and 7 has a cyclicity of 4. Though this cyclicity concept in case of tens place is a little difficult concept that we have, so we avoid it as much as we can and we look at the other better methods that we have. So let's look at the question that we need to solve using the concept of cyclicity. Finds the tens place digit of 7 raised to power 2000. So if I go back and look at the cyclicity table that I have, cyclicity of 7 is 4. 7 has a cyclicity of 4. So using the cyclicity table, I can look at the cyclicity of 7, which turns out to be 4. So tens place digit of 7 raised to power 4 will be equal to the tens place digit of 7 raised to power 8 will be equal to the tens place digit of 7 raised to power 4n. So this number is of the power of 4n. Because this number is divisible by 4, that means it leaves a remainder of 0. So if I look at the tens place of 7 raised to power 4, 7 raised to power 4 ends up in 2401. So if I look at the tens place digit, which comes out to be 0. So this number will have a tens place digit which will be equal to the tens place digit of 7 raised to power 4, which is 0. So the other thing that you can use is a generalization thing. If the last digit is 1, 3, 7 or 9. So if the last digit is 1, 3, 7 or 9 and the power is a multiple of 20. And the power is a multiple of 20. The last two digits are always 0, 1. So if you go back and look at this question also, this question I can solve it with the help of generalization also. It ends up with 7 and the power is of the form of 20n. So the last two digits will be 0, 1. Instead of using cyclicity, I can use generalization for odd numbers and I would look at the last two digits as 0, 1. But this can only be applied if the power is of the form of 20n. If the last digit is 5 raised to power anything, n being even, the last two digits will always be 25. So let's look at now the method. Now this is the generalization thing or the cyclicity thing that we have done. But let's look at what is the method in finding out the tens place digit. So the method is, which this can be applied to each and every case. You need not remember the cyclicity thing for a tens place digit. You need not remember the generalization. This method is a universal method that will help out in finding out answers to any kind of question. So for a number ending with 1, if the unit digit is 1, and this 1 I am talking about the unit digit. I am not talking about the tens place digit. I'll make you understand with the help of an example. Find the last two digits of 41 raised to power 786. So if a number ends up in 1 raised to power anything, the last digit would always be 1. So last digit is already fixed. Now the tens place digit would be obtained by multiplying the second last digit, which is the second last digit 4 here, with the last digit of the power. So I'll multiply the second last digit with the last digit of the power. 6 into 4. It is what? 24. I'll keep 4. 4 will be my tens place digit. So the last two digits will be 41. 1 will always be there because if a number ends up with 1, raised to power anything would always end up in 1. Second last digit would be obtained by multiplying the second last digit with the last digit of the power. So you get 24. You will always keep the last digit, which is 4. This will be your tens place digit. Let's move ahead and let's look at numbers ending with 3, 7 or 9. So if the unit digit ends up with 3, 7 and 9, I will convert it into a case ending with 1. So I will convert it into a case ending with 1 and then proceed ahead with the method that I have learnt already for a number ending with 1. Let's look at an example. The question is, find the last two digits of 43 raised to power 784. Now we need to convert it into a number such that the unit digit would end with 1. So I'll keep 4 inside and 196 outside. This power of 784 has been split up as 4 into 196. Why 4? Because I know 3 raised to power 4 ends up in 1. So I'll find out the value of 43 raised to power 4. I know that 43 raised to power 4 ends up in what? 1. Now to find out this thing, I have another method which I'll just let you know. So first let's look at it. The last two digits that comes out to be are 01 of 43 raised to power 4 raised to power 196. So I've already converted into a way that it ends up with 1. The unit digit would be 1. The tens place digit would be obtained by multiplying the second last digit, which is what? 0, with the last digit of the power, which is 6. So I'll be doing 0 into 6, which is 0, which is your basically tens place digit. So the last two digits will be 0, 1. So if a number ends with 3, 7 or 9, I will try to convert it into a case that ends with 1 by splitting up the powers such that the internal power when solved gives me 1 at the end, and to that power also I will only keep the last two digits. I would not find 43 raised to power 4 exact. I would only need the last two digits of 43 raised to power 4. Now let's understand the procedure once again. We need to convert it into a number such that the unit digit would end with 1. For that, I need to remember that 3 raised to power 4 ends up in 1. 7 raised to power 4 ends up in 1 and 9 square ends up in 1. So if you have any powers, split it such that the internal power would solve up and give you the value of 1 in the end. So if a number ends with 3, 7 or 9, the power has to be split up such that this value when solved for this number ends up in 1. What happens if a number is an even number? We have already done the case of number ending with 1, 3, 5, 7 and 9. Let's look at the numbers that end with 2, 4, 6 or 8. Now for this we need to remember certain things. First one being 2 raised to power 10 ends up with 24, or the value of 2 raised to power 10 is 1024. 2 raised to power 10 raised to any odd power would result in the last two digits as 24. 2 raised to power 10 raised to any even power would end up with the last two digits as 76. So if the power is odd, the last two digits would be 24. If the power is even, the last two digits would be 76. And the last thing that I need to remember is 76 into any power of 2. The last two digits are given by the last two digits of that power of 2. So if you have 76 into 2 raised to power n, the last two digits will be given by the last two digits of 2 raised to power n. 76 will have no effect on finding out the last two digits. So if it is 76 into 2 raised to power 5, the last two digits would be 32. If it is 76 into 2 raised to power 6, the last two digits will be for 2 raised to power 6, which are 64. Similarly, 76 into 2 raised to power 10, the last two digits will be for 2 raised to power 10, which is 24. Let's look at an example. Find the last two digits of 2 raised to power 662. So I will try to split it up into 2 raised to power 10 inside, which is 1024. I know the last two digits. Raised to power. So I'll break this power 662 such that it is 10 into 60, which is 600 plus 2. 10 into 66, which is 660 and plus 2. So I'll keep 2 raised to power 10 inside, 66 outside into 2 square. Now if I solve it out, I know 2 raised to power 10 ends up in 24. So 2 raised to power 10 ends up in 24, and any even power would end up in 76. 76 into 2 raised to power 2 or 2 square would end up in the last two digits as that power of 2. So again 76 will have no contribution towards it. Let's look at another example. Find the last two digits of 12 raised to power 662. Now for this, I will break up 12 into 4 and 3 because 4 is even, 3 is odd. So I will separately find out the last two digits for odd and even numbers and then combine them in the end to get to my final answer. So if I look at it, 4 raised to power 662 can be separated as 2 raised to power 10. The power is 132 into 2 raised to power 4. So this power has to be splitted up such that the value becomes equal to this, and 3 raised to power 662. Now for 3, I'll keep 4 inside because I know 3 raised to power 4 ends up in 1. And the rest of the power would be 165 and 3 square. So if I just solve it out, 2 raised to power 10 into any even power 76 into what is this? 2 raised to power 4, which is 16. The answer for these two would be 16. Now 81. To find out the last digit, it will be 1 for it. It will be 1 for this, and the last digit would be 8 into 5. So I will look at, this will be 16. If I solve this, 8 into 5, 40. So I'll keep 0 as the tens place digit. It will be 0, 1 into 0, 9. So I'll just have to solve these things to get to a final answer of 44. So the last two digits of 12 raised to power 662 are 44. I hope you have understood this thing. If you have not understood it, you can always go back and revise the concept. This is very, very important to understand how to find out the last two digits.